Hey everyone. So, today we're going to continue talking about some stoichiometry. But before I do that, I have a little example I want to talk to you about. Let's say me and my neighbor are farmers. We grow fruit. I grow watermelons. My neighbor grows oranges. All right, and we have a deal. Um, I can't eat all my watermelons. He can't eat all his oranges. So we decided to swap. And we decided it's fair for me to give him 2 watermelons and he'll give me 15 oranges. And that's kind of the trading ratio that we're going to have. So if I give him 4, he'll give me 30. If I give him 6, he'll give me, 45, and so on and so forth. So that's kind of the system we have now. Day comes for us to trade, and I call him up, and I'm like, "All right, buddy, I have 100 pounds of watermelons, so bring the oranges." And how many oranges will he bring? So think about it for a second. If I tell him 100 pounds, what does he actually need to know in order to actually gather up all of his oranges? Well, he needs to know how many watermelons is 100 pounds of watermelons. He needs to know how many pounds per watermelon we have. So, and then do a little bit of calculations there. Once he knows how many watermelons I have for him, he can then gather up how many oranges he needs to bring. Um, so that's that. Um, that's kind of what we're going to be talking about here. Yesterday, or not yesterday, previously we've talked about moles to moles, numbers to numbers when it comes to stoichiometry, and that's fine. But now we have to think about weights. We have to think about grams. Why do we need to think about that? Well, how easy is it to get the weight of something, of a sample? Pretty easy. You just need to, get out your triple beam balance and weigh it. How hard is it to get the number of atoms? A little bit harder. So it's this is why we in stoichiometry need to go from grams to moles and then do our stoichiometry. So that's what we are going to be doing today. We're instead of going from moles to moles, we're going to go from grams to moles and then moles to moles and then from the moles back to grams. So for example here, we have ourselves this balanced equation, and if we have 10 grams of aluminum oxide, how many grams of oxygen will be formed? Whew, okay. So we know we have 10 grams of aluminum oxide, and we are going to try to get to grams of O2. Now, if you are, really quick and not thinking and jumping the gun, you might think, oh, well, I got my ratios right here. I can just put aluminum oxide on bottom and oxygen on top, 3, 2, and bang, bang, boom, I'm done. I can now do my stoichiometry. The thing is, though, remember, just like before, with the fruit example, we don't know how many moles of aluminum oxide we actually have. We just have the grams of it. We don't have the number of this. So, before we go through and do our stoichiometry step, we have to go and turn this weight into a number of, an amount. And for that, we use moles, grams to moles. Now we need to think aluminum oxide. What is aluminum oxide's molecular weight? 101.96. 101.96 for aluminum oxide. Cool. So we know it's 101.96 grams per mole. The grams can cancel. Now we have moles of aluminum oxide. And once you have moles, now we can go through and do that Stoic step. Aluminum oxide. The aluminum oxides cancel. And now we have moles of oxygen. Moles of oxygen. We don't want moles of oxygen. We want grams of oxygen. So now we need to do one more thing. Moles to grams. Now we're going to have grams of oxygen. I know oxygen is 32. Each oxygen is going to be 16, so it's going to be around 32. Now on this side, we have grams oxygen, and we're trying to get to grams of oxygen. So we set up our dimensional analysis correctly, and we can go. We can plug and chug this. Calc. Let's go through and do this. So we started with 10 divided by 101.96 times 3 divided by 2 times 32. Bam. And we get 4.70 or 4.7 grams of oxygen being produced. And there we go. So this is going to be your next, your next task, your next thing to do is going from grams to moles, then moles to moles, moles to grams. It's not horribly difficult. You guys know how to go from grams to moles. We've done that quite a bit. The moles to moles, I think, is fairly straightforward. And then going back from moles to grams. So this is basically just 3 separate problems. And you can think of it like 3 separate problems if you want to. If you're the type of brain that thinks, okay, first do this, then do this, then do this, that's fine. Go for it. I like to think about it like this because this is, to me, this is like just one problem as opposed to a couple, 3 short problems. All right. This, I'm going to say this, just look for stoichiometry roadmap in Google, and you'll find a figure similar to this. This will kind of help you, give you a little cheat sheet, a little roadmap for doing stoichiometry. You have grams. You use the molar mass to go to moles. Moles, use the mole ratio from the balanced equation to go to moles found. Use the molar mass again to grams found. All right. There's another thing you can do. We haven't really talked about it. Using volume of a gas. We'll get to that later. Don't worry about that right now. But grams to moles, moles to moles, moles to grams. That is what you're going to be after. I have another worksheet for you, of these. It's going to be very similar to the moles to moles one that I gave you before. This one, though, is you're going to have to convert this into moles of H2O. And then once you have the moles, do your balanced equation. Ooh, this one's easy. It's just 1 to 1. And then go moles of CO2 to grams of CO2. That's that. So go ahead and work on that worksheet. Show me your work. Make sure to show me the work. You got to show your work. And then submit that. All right, guys. I'll see you guys later. Have a good one.